This is 2 times in a row the mic didn't work. It worked before, but not after I switched scenes. That's cool. I have to unplug and plug it back in, but it doesn't feel like it should be a cable problem because it was working like just seconds ago before I switched the scenes. So maybe something else is going on. Anyways, regardless, welcome. We are going to be continuing on with the BBECS delete, sort of like update, rewrite, sort of refactor, however we want to sort of like feel about that. The idea here is, in our world mod, we have this delete by ID, in which we're setting the ID to be deleted. Okay, so now we know what to delete, and then the next thing is like, okay, well, how to actually delete this. There's a lot here that I think is not necessarily that great, that we don't want to like have to deal with. So what I want to do is sort of like go through this and figure them out. So we know that we're going to have IDs, and we know that they're going to be, we're going to have the to be deleted. We know we're going to have the IDs, but then the other thing we know is every single entity has to be deleted, and every single entity has an ID, meaning that there's never, like, of those ones, the index of those is going to match up with the index of the bitmap. So I'm thinking that we can use the bitmap to find out what the index is to be deleted for all of the components all the way down whenever we need to go. So we need to find what the bitmap index to be deleted is. And I think that's going to be first a query to get the indexes to delete. We have to figure out like who is deleted. So we need to get the deleted by, I think so. Okay. So let's do I guess all queries results is equal to self dot query, and I want the to be deleted. Oh, all I want is just a vec. To be deleted. You return this vector. I can then want to grab the first one out so that all right, so that gives me that vector. We don't know how many of items we're saying that we want to delete at the exact same time. So we have to loop through these and figure out what the indexes are. So let mute, and this is going to be the bitmap indexes to delete. I'm going to just make a new vector here, and then we're going to push into this based upon this to be deleted query. So we're going to loop through that. Okay, so we'll get our index, and then we're also going to get the, I guess, like just to be deleted. Okay, so we need to find out if you're true or not, so which means we need to cast you. So be a reference to an RC. Okay, so now we have that as an RC, then we have to borrow it. So you're wrapped. Because I don't think I can shadow this again, can I? Oh, I can. I can just shadow this right here. So to be deleted with this is no longer available to me, but you are now available to me as just a ref of the boolean of the current index of whatever this is. Oh wait, maybe not. Or not. To be deleted is this component data. Do I need Oh, right. I can't do the question mark there because I'm in a for each. I have to unwrap. And I wasn't able to get the try for each to work. So we have to unwrap there. That's what it is. So I could in fact do this. Shadow this. Right, type annotations needed. Don't worry about that. We're still working on it. Okay, so we get the to be deleted query. We now figure out what the boolean is. So if this is true, so if dereferenced to be deleted, if you're true, then bitmap indexes to delete, push the index. All right. All right, so that gives us delete. Okay, so now we have an index basically of the bitmap indexes. Now what I want to do is I want to grab out the I guess go into bitmap and figure out the actual indexes to delete for each entity. We're using the same keys in the hash map inside of the bitmap. So I could maybe make like a bitmap, a hash map with the same keys as like the components and the bitmap, but then also a vector of indexes to delete based upon that. I think that might be the best way to do this. So that means heading into bitmap. Okay, so we're gonna do pub function delete delete by entity index. And we're going to take in a vector of the indexes. Which you're going to be a vec of usize. And I want to return a hash map with string as the key. And let's also make this a full result with then hash map inside, string And then this is going to be a vector of view size. Okay, so let's first start by creating this like results hash map. So this is going to be the component indexes to delete. You're going to have to be mutable so we can update you. And then we're going to return okay and these. And this. Okay. All right. So we have, if we take a look at our whiteboard, we have something like this. So we're going to hand them a ID that corresponds to here. I mean, it also corresponds to here, but we notice that every single entity here has and is deleted, whereas it doesn't necessarily have everything else. So, okay, we give them something that corresponds to one of these IDs, and I need to... Well, okay, we know which one that it is. That's not really a problem. We need to go through each of the locations and essentially delete that index inside of each vector. But at the same time, we need to find out if there's any falses to the left. So for example, if we're deleting this asteroid right here, this one is going to be for location, delete 0, 1, 2, 3, 4, index 4. Whereas here, it's delete index 3, and then 4, and then 4. And that's because there's a false to the left of it. So that doesn't seem super fun. So I want to loop through. I think we can do like a standard loop through. So for, and I think this will give me the component name, and it'll also give me the sort of like bitmap self dot entity map. Yeah, okay, so that gives me that. Well, the first thing that I can do is I can insert component indexes to delete with an empty vector. Now, is that true? No, I probably don't want to insert it until the very end. But we can figure out, based on this component name, we could then figure out the indexes, the component indexes to delete. No, I don't want to lose that. So we're going to get that, and then down at the bottom here of this for loop, we're going to now insert this into the component indexes to delete. Our key is going to be the component name, and our value is going to be the indexes to delete. Okay, and then for each one of these, we're gonna need to delete the one question. But then also we want to like loop backwards and find out how many falses are there to the left of the index that I'm looking at. So what is that going to look like? Let's say I do this as like another function down here. So function count falses before entity index. Bug0, hello, good morning. Hey, what VS Code extensions do I use to work with Rust? The extensions that I'm using for Rust specifically, now I've got code LLDB installed, but I haven't used it yet. I've been told that it's pretty good, but it's unknown. I haven't tried it yet. Crates is really nice. It if I open up cargo.toml here, not that cargo.toml, this one. It gives a check mark next to each version, and then I can sort of highlight over it and change which versions I want to use very easily. Let's see, what else is here? Rust Analyzer is a must, in my opinion. I use this over RLS. In fact, I don't even have RLS installed in here. And I think that's it. When I was doing a little bit of like WebAssembly with Rust, I also had the WebAssembly. It's not really Rust specific, but it allowed me to look at the output WebAssembly a lot nicer. I noticed that they're recommending Rust for me because I didn't install it. Just Rust Analyzer is all I really needed. I guess if you're going to go minimized, Rust Analyzer is all you need. And that's going to come down here. It updates every single week. So it should ask you, hey, we're out of date. Can you update me? And then you do it. So I hope that helps. Okay, so count falses before entity index. We're gonna have this be a self. I also want to have the vector in question. And so it's gonna be a vector of, okay, so we're gonna have like our list. So components, this is a vector. You can just be a reference to a vector of booleans. And then the index to check, which is a usize. And then we can return a result with a vector of usize. No, it's just a count, right? Oh no, but it should be usize because then I can do math on it easier. Okay, so I'm not sure how I want to deal with that. Thanks very much for all that. I think Rust Analyzer might be good for, is it the one that provides the auto completion? Both provide auto completion. So both can help you with auto completion. Do you see these like right here? Where I have like inserted in like the types in, this is something that Rust Analyzer is doing for me. It can be turned off, but I kind of like it. It's good for streams so like people can see what type this is. It's also, I've just grown to like it too. It lets me know if I'm screwing up, if it doesn't show up there. RLS provides file auto completions, and Rust Analyzer provides like some other types of auto completions. Both provide auto completions that the other doesn't provide. You can try to run with both them on. That will tax your system and potentially cause problems. I ran into an issue when I was trying to do that where they were essentially fixing each other's problems, and then that corrupted the file. Like it just added a bunch of crappy code in the system. That was terrible. Okay, that's what you meant. Yes, it does. These are actually like truly auto completions. The code isn't actually here. It's just like visible. But yeah, like they're both okay, but I think REST Analyzer is a lot better right now. It's also like being updated so much. All right, so how do I want to do this? I want to take, we have this vector of a bunch of Booleans, and I have an index that we're going to check. So we're going to go to the index of these Booleans. Okay, first of all, we should check to see if we're out of range. If we're out of range of this, what should I return? Should I return 0 or should I return an error? If we look here, if we ask you, okay, so the index of asteroid with this one is going to be out of the range. Oh, that's going to be interesting. Okay, so because 0, 1, 2, 3, 4, but then 0, 1, 2, 3 out of range. I could return this as an error and then catch that and then decide like that I just want to make that a 0 in the other one. So we can head over into errors. This could be just a very generic error, which is out of range in vector. Let's see. You tried to access a vector with an index that is greater than the length of the vector. Okay, so we'll do an if our index is greater than or equal to components.length, then we're going to do an early return here of an error. Out of range in vector. Like that, okay? We'll have to catch that up here. You need to head off. It's a little past midnight for you. Oh, thank you so much. And good luck with your REST programming. All right, so you're just upset because I'm not actually like returning this result usize. If I do something like okay 0, this should be happier. But all right, so what's next? We're handling the case that we're like too high. Then if we're like less than that, I probably want to get a slice of, I bet I can get a slice, right? Okay, some methods. Okay, so extracts a slice containing the entire vector. I don't want that. There is this range thing that I can do. We can splice. Creates a splicing iterator that replaces the specified range. Okay, I don't want to replace. I don't want to split. I'm surprised there wasn't like a slice in here. Not sure this is what I want. It does give me these. Okay, these two. So if I give it an index of that chunks, returns an iterator over chunk size elements of the slice at a time starting at the beginning of the slice. The chunks are mutable slices and do not overlap. Okay, so maybe chunk. I could do chunks and contains? No, probably don't want that. Okay, so we can partition at index. Oh, that's deprecated. Select nth unstable instead. Oh, that's fun. Oh, our chunks goes over from the right to the left. Okay. Okay, they have the R splits. That means they're going to have a split too. Returns an iterator over subslices generated by elements that match predicate. Oh, okay. So you hand it a. So I probably want to chunks that. Let's head to the playground and take a look a little bit at this a little bit more. So let's say I have let our like components map is equal to a vector of like true, true, false, true. Let's do this. So then if I want to do a chunk over this, I'm gonna do a for something. It's supposed to be map in components map dot chunks. And then pass that the index, so 0, 1, 2, 3. And let's just debug. Map. See what you are. Chunk spool is not an iterator. Okay, I thought it said it returned an iterator. Wait, was I wrong? Returns an iterator over chunk size. Okay. So how do I use this? Okay, so we have this. Yeah, we're calling like next on it. Oh, I only need the first one. Wait, can I There might be a completely easier way to do this. And I just, instead of doing that, I just debug. Components, map. I want to do this as a reference and like 0 dot dot like 3. So 0, 1, 2. That should give me those. True, true, false. Okay, okay, okay. That gives me everything up to, but not containing. Oh, okay. And then we can just count the number of these. All right. So then in here, when we call this, it's going to be a reference. Is it still a reference to a vector, or is it an array? Because we don't know how big it is. Because it might be different sizes. Interesting, okay. So really, I just want to count falses. I don't even need the index. I don't need to do any of this, really. We can do this out of range of, let's see. What if I give you something that's out of range? 0, 1, 2, 3, 4. So let's do 5. Let's do 6. Okay, so you're just gonna panic at out of range, okay? Oh, okay. So if you're gonna panic out of range, I have to do that check somewhere. Let's do that. Okay. All right, I like the idea of having this here then. So we can have this error return. We can then get our slice, and then I can just count the falses in it. Maybe like filter it down to a single number, and then count the length. There's a couple ways I can do this. Is there like a count? That's not what I was expecting. Is there an add or a sum? Probably off the iterator. So if I have this true, true, false, false, because true and false is often used by like 0 and 1, can I just like sum these together? So do something like let sum equals components map dot iter dot like, I don't know if that works. then debug sum. Type annotations needed. Okay. So you're true. Are you a U8? Can I say that you're just gonna be like a U8? No, okay, so trait sum bool is not implemented for U8. And I don't think I can like cast booleans as like something else. That would have been cool, but I guess I can't turn these into like ones and zeros. Now I could just go and convert them, but I think we can just use fold then. So, okay, so if you're greater than the outer length, we get the out of range. Oh, this doesn't mean that, because there could still be falses to the left of it. Because like, for example, what if this is also false? So here, 0, 1, 2, 3, 4, 0, 1, 2, it wouldn't be even with even with like asteroid here, 0, 1, 0, 1, 2, 0, 1, you would be out of range, but there would only be one false to the left of it. And if it was something like this, there could be two falses if I try to zero, 1, 2, 3. So this is index 3, but it's only going to be 0, 1. Index 1 that I have to delete. So in reality, what I do is if it's out of range, I just count all the falses. I don't think that works either. Because what if there's like a false over here? But you'd be like index out of bounds there? Ooh, I don't know. Let's see, because this is 0, 1, 2, 3. So position 3, but 0, 1, 2. If you were false also, let's say, I need to go back by how many? Actually, I guess to make it so if we're doing another asteroid here and you're true, then you're 0, 1, 2, 3. So you're index 3. But the values of velocities are going to be basically something like a point, point, point. Like that's all we're gonna see in these velocities. Which means 3 is obviously out of bounds because it's length of 3. So there is no index of 3. But I don't want to just delete the last one, and I can't just count up all of these. Because that would be, okay, 3 of these falses. That would then tell me, oh, go back, go start from the right, go back by 3 and delete. But I really want to delete this one right here, the middle one, not the first one. So how am I gonna know exactly which one to delete here? I can... Right, so the entire idea is I have to figure out where I am. Okay, so how many falses total are there? So there's three total. How many after me? Ooh. Because if this is false, also like that doesn't count either. Wait, but these are all in here, right? So the index includes falses. So I can always slice to here. Because we're not talking about in reality, we're just talking about I do the iterator to here. Because they're always going to be in with these values. So I just need these. I think that's all I need. So I want to count falses. Before index. So we know it's exactly there. So I want to get our slice. So that's gonna be something like components of 0 ... index. Now if you're the index, I think I need to do that to get the exact equal. Then I think I can do it, turn this into iter. Then I can fold. So I want the actual like let count, let falses equal to our initial number is going to be 0. Then what are we going to have here? We're going to have the value, just the value in here. So it's going to be true or false. Oh, Svekaz, you have a play rest. Oh, did you just do this for me? Oh, you did. Okay, hold on. Let me... we have our vec, which is our true, false, false, everything. We have my falses. Okay, so we iterate. Okay, then we're going to filter it, and then you collect it, and then debug my falses, which if we run this, we'll see is this. I could do it as a filter. I wonder. Oh, you know what I realized? This doesn't take this takes 2 items, right? This takes like the collection, so like the total, and like the current. There you go. And then if not current, so if you're false, so if not current, then total, I guess you need to be, oh, we could just return from here. So total +1, else return total. So if I do that, that should fold it all together. It's basically like filter, except I'm converting it into like a single number at the same time. And so I want you to be a size. I think that'll get it for me. So for example, if I do this, you come back out here. Thank you. Got my tea. Okay, so total falses is I want to take off of my vec, so this is going to be my vec. Let's do 0 through 0, 1, 2, 3. Let's go through here. We iterate, we fold, we give it our 0 initially. We do this entire thing, and then falses. We get total falses is 1, 0. Okay, so only 1 here. And if I go to 4, that should give us 2. There we go. Okay, so that gives us the total number of falses that are within this slice. And so like, yeah, fold is one of my coolest tricks. I love it. But thank you so much, Svekas, for that code. I could also do the filter and then just get the length of it. Just get the length of the new item. That also works. Because if I just do the filter, it's gonna be like a reference to my vec of like 0 dot dot 0 1 0 1 2 3. Iterate if we filter and collect it back into Boolean, and then we can do my falses dot length. That would this should also work. Yep. Okay, that gives it to us here. Like I can see it going either way. Ooh, wait, can I clean this up by turning, like, converting? Can I do something like debug true as a U8. Can I do that? Oh, okay, you're a 1. How about like a U size? You're a 1, and then false. Okay, so I can do this use. Ah, there we go. Okay, so then I can just add in here. So then instead of like this entire if statement, we could just do return total plus current as a U size. And that makes it more of a one-liner. What are you upset about? Oh, maybe let's take a look at yours. Yeah, okay. So this would also work too. Let's take a look at this new version. Dehisic, good morning. Hello. Well, morning for me. Good morning, afternoon, evening, wherever you are. I'm working on an ECS sort of library, create for myself and my own simulations and games. Just sort of like to learn them all, and I'm working on delete. So I'm trying to figure out the indexes to delete for each of these, for each of my component vectors. Okay, so here we have my false is equals. Okay, so we have our my vec. We get our iterator. We get a slice of the vector. We iterate through it. We then filter. If it's false, we clone. Okay, we clone after the filter. We clone, then we collect, and then we return the length. Yeah. Either of these ways work. I don't know if there's like a best solution for this. It's either like filter it or fold it. Either way works. Either way is really nice and clean, I think. So, what we can do is get our total falses equals our components of this. We get our slice. So let's try your way. We can do this filter. We do have to do a collect. We don't have to do a collect if we do fold. But we could do filter. We don't have to do U anymore. Then we're just gonna have the current, which is this Boolean. And so I want to return the current. I want to return the opposite of the current. If it's true, I want it to be false. If it's false, I want it to be true. So can I actually just do this? So wait, length is 3. That should be length is 2. Wait, then opposite. That should be 2 then. There you go. So now I can return the opposite of current. Okay, so that gives me this filter. I then want to collect this. You're going to be a vector of Boolean. And then I want total falses dot length. Could I just have a reference to it? No. So I have to do that cloned, don't I? Cannot be built from iterator over elements of... Okay, so let's do a vec of boolean. We'll have to clone this here after the filter. Interesting, there's clone and cloned. Guess cloned. Okay, here we go. So we cloned it. That gives us our total falses. Then we're going to return the OK and total falses length. That's going to give us the number of falses before index. If I want before index, then I don't need this equals. I don't need to set it that. It could just be up and to index, but not inclusive. Because I don't actually care what the index is. We're going to delete on the vertical down. Okay, so this gives us the total falses here. I can now use that up here. So okay, so we for this we get our indexes. To delete is this new vector. We're also getting these entity indexes. I have to go through all of these and delete one at a time. Is that true too? Let's see. Then, okay, so indexes to delete. We have our entity indexes. We have to loop through our entity indexes for each of these, for each of the components, which is this bitmap. Then we're going to pass that into our count falses before index. Oh, so that's going to be another for loop essentially. And then that's going to give us the count of them, which is going to be the current index minus however many, minus these falses. I think that's what it's going to be. So we have to now loop through each of these entity indexes, or the index and entity indexes. That's going to give me a U size here. Then I want to grab, okay, for entity index, I want to now count the falses before the index. subtract that from the current index and push that into the indexes to delete. So we're going to do indexes to delete that push our current entity index minus, so entity index minus self dot count falses before this. This is going to be our bitmap. And the entity index. Why are you yelling at me? Because... Oh, okay. Okay, so it's Clippy yelling at me. So it wants me to change this to be like this with Boolean in it. Okay, cool. All right. I think that logic works for us getting, okay, so we pushed in our indexes to delete. We then insert that into this hash map, and then we return this hash map. We don't need you at all. Now, of course, delete by entity index. I actually want to do the delete too. So that is, once I go through and do all these, I then want to actually do the deletes. I wonder if I want to rename this to be like calculate. Calculate component indexes to delete. Excuse me. And then we want to actually do the delete too. So it's gonna be pub function delete entities by index. So we're gonna then get the same entity indexes. So entity indexes, back to the U size, that should be fine. I don't know if I need to return anything. Maybe a result. But I don't think I need to return anything inside of it. So in this case, we're going to loop through all, we're going to do very similar here. I want to loop through all the component names, and we're going to remove out of the index for each of these indexes. I should probably do reverse for this. So entity indexes, I can reverse these entity indexes. That might be best. So that reversed indexes is equal to the indexes dot reverse. So that way it will remove them from the right to the left. It'll shift everything over appropriately and we won't run into trouble. Then we're going to do our for loop. I don't care about the keys. This can be for our components in self.entityMap.values mute. That gives me the mutable reference to these vectors. Then, okay, so entity indexes, we're going to now just remove out of here. So components, dot remove by the index. Oh, okay. For each of these components, we now need to loop through the entity indexes. Oh, you don't return anything. It just does the thing to you. Just mutates it. Yeah, mute self. Reverses the order in place. I wonder if I can do that inside of here. No, I only want to do this once. I want to do that once, and then inside of here, we're now going to loop through the entity indexes. Okay, so empty indexes. Well, I guess like for the index in entity indexes. Then we're going to remove it from these components. So components dot move entity index. You don't return. You return the element, but I don't really care about that. You need to be mutable. I don't put the mute there, put the mute here. I don't want to move out of here. So there we go with that. And then I want to be like that. Okay. Now I can run this in like a two part, like two punch, 1-2 punch. We'll calculate the component indexes to delete. Then we'll delete them in the actual components, like a library that we have, our module, and then we'll delete them from here. So in U, we have to calculate. So this is the to be deleted. Okay, so bitmap indexes to delete. We push you into here. This is our update. Now we can get the actual like full to be deleted now. So let component indexes to delete is going to be equal to self.bitmap dot calculate those to delete. Oh, this is fun. You take entity indexes, which is the bitmap indexes to delete. So that's going to be bitmap indexes to delete, and that's it. And then question mark. Update, you're gonna have to be a mutable self in here because we're mutating. That being said, you don't need to be mutable. We're not mutating anything in here. However, the very next one, we will be. So then once we have the component indexes to delete, which gives us this hash map, sort of like the map of what to delete, time for us to actually do the delete to the bitmap. So now we're going to do is self.bitmap.delete entities by index. And this is also the bitmap indexes to delete. And we do that. And you need to be owned. I wonder if I could just do a reference. I could give you ownership. Because I'm done with it now, right? Oh, it's already been moved. It's been moved here. Okay, so you should take a reference to this. Okay, so we get that. We delete out of the bitmap. We should be happy now. Okay, I don't need to do this anymore because it's already... Come on, let me choose you. Now, I think our problems are just in asteroids now. Can I do not asteroids? I said not asteroids. BBECS. Okay, that's just yelling at us inside of here. That's... Okay, here we go. Bitmap ECS. Okay, we have some warnings. You don't need to be this U size. You're just gonna be a U size. Okay. Oh my gosh. Okay, it's a lot easier for me to just look through here. Don't need to look at you. You're fine. Okay, in world, we have warning here. Okay, select component indexes to delete. We're not using that. That's acceptable. Okay, no other warnings or errors. If we run the tests in here, I'm guessing they should fail because I think in deleting, we're trying to make sure that you actually delete. Is that true? Or did I not finish writing these tests? I'm actually trying to ensure that they deleted. So these tests should fail still, but all the other tests should work. So let's cd into ECS, cargo run, not cargo run, cargo test. And it should just be like a left doesn't equal right. Perfect. Because left, we still have this 0, 0, and right, we're supposed to have this 10, 0. And if we look what we have two entities that we created here, one with 0, 0 and one with 10, 0. We're trying to delete the first one. So delete by ID here. If it's the 0, 0, we then update the world, and then we're trying to see like, hey, we should only have one length. and 0, 0. All right, so it is 8:15, so I don't think I'm gonna start like doing the next thing fully yet, but we can take a look at what it's gonna be. We now have these component indexes to delete, which means the next thing to do is to go into the entity data and write the delete function here. And that's going to then actually do the deletion for all the components in there too. And then I think we'll be back to the asteroids again. Unless we've forgotten anything else. Like we did delete. We might want to like do a little bit more complex testing with delete too, to like add in components that don't have some things and have some other things and test those out. But I think that's going to be the general idea of it. So I'm going to go ahead and stop the YouTube video here.